You know that feeling, right? You're deep into an algebra problem, you're doing everything right, and then one tiny mistake just ruins the whole thing. Well, today we're tackling the topic that causes that feeling more than any other: adding and subtracting rational expressions. It can feel like you're hitting a brick wall, but I promise you, there's a clear path through it, and we are going to walk it together.
I mean, this just says it all, doesn't it? That feeling of pure rage when one tiny slip-up sends the whole problem off the rails. If you have ever felt this, trust me, you are not alone. It's probably one of the most common and frustrating hurdles in all of algebra.
But here's the good news. It really doesn't have to be this way. The key isn't just to practice more and more. It's about having a reliable, step-by-step system you can count on. So right now, let's build that foolproof plan.
First up, let's actually define what this roadblock is. Why does this specific topic trip so many people up? Well, it almost always comes down to forgetting one single, super important rule that governs all fractions, from the simple ones you learned in grade school to these complex-looking beasts.
And that rule, that one big idea, is all about finding a common denominator. To see how this works with these crazy-looking expressions, we're going to rewind the clock a little and start with a concept you've actually known for years.
So let's look at something really simple, like 2/5 plus 3/10. You can't just add the tops and the bottoms, right? Your brain automatically knows you have to find a common denominator first, which is 10. You turn 2/5 into 4/10, and then you can add. Believe it or not, that exact same instinct is all we need to solve the harder problems.
Think about it like this. The problem on the left? Piece of cake. 2/7 plus 3/7 is just 5/7. Done. But the one on the right makes us stop and think. Why? It's simple. The denominators, 7 and 5, don't match. Our first job is just to make them match. And look at this. It's the exact same thing with variables. The problem on the left is easy. The denominators are both x minus 2, so we just add the numerators. The problem on the right looks intimidating, but it's the same situation as the last slide. The denominators just don't match, yet. Our only job is to make them match.
So how do we do that? Well, welcome to your toolkit. This is where we stop guessing and start building a reliable system. We're going to put together a 4-step method for finding what we call the least common denominator, or LCD for short.
The LCD is our goal. It's the common ground we need for our fractions. I like to think of it as the smallest possible box that all of our original denominators can fit into perfectly. Once we find that box, we're halfway home. Now, what's really cool about this is that it turns a complicated idea into a simple recipe. You don't have to guess, you just follow the steps. First, factor everything to see what the building blocks are. Then list every unique block you see. Find the biggest pile of each block from any one denominator. And finally, multiply them all together. That's it. Okay, this right here is the master plan. This is the foolproof strategy for every single problem you'll face. 1. Use your toolkit to find the LCD. 2. Rewrite the fractions so they share it. 3. Combine the tops. And 4. Simplify. That's it. Every single problem follows these 4 steps.
Okay, so we have the plan, but like that student said at the very beginning, it's often that one little thing that goes wrong. Knowing the method is only half the battle. Now we need to learn how to spot and avoid the most common traps. And here it is. Math teacher Brian McLogan points out the #1 mistake, the single most common error he sees. It's all about that subtraction sign. When you subtract one of these expressions, you're not just subtracting the first term, you're subtracting the entire numerator.
This is exactly what he's talking about. On the left, in the incorrect version, that negative sign only hit the x. But look at the correct side. That negative has to be distributed to both the x and the 3. Forgetting to do that is the single fastest way to get the wrong answer. Your best defense? Always, always, always use parentheses. And here are the other usual suspects. Never, ever, ever add or subtract the denominators. You can only cancel things that are multiplied together, not things that are added. Always factor first before you do anything else. And finally, just slow down. Most mistakes aren't from not knowing the concept, but from simple sign errors. So take a breath and check each step.
All right, theory is great, but let's actually see this thing in action. We're going to take our 4-step plan and our list of traps to avoid, and we're going to walk through a complete example from start to finish. Okay, here's our problem. And yeah, I get it. At first glance, this looks like a monster. We're subtracting and we've got two different trinomials in the denominators, but we're not going to be intimidated because we have a plan. So let's start with step 1, factor. So step 1 is to factor. For that first denominator, we're looking for two numbers that multiply to 20 and add to 9. That's going to be 4 and 5. For the second one, we need two numbers that multiply to 12 and add to 7. That's 4 and 3. And would you look at that? The second we factor, we see they already share a piece, the x plus 4. Now for step 2, find the LCD. We just list all the different factors we see. X plus 3, x plus 4, and x plus 5. So our LCD is just all three of them multiplied together. Now we look at what's missing. The first fraction needs the x plus 3, and the second one needs the x plus 5. So we'll multiply the top and bottom of each by its missing piece. Step 3, combine. We write everything over our single LCD. And this is so important. Notice we've put parentheses around that second numerator part. We are subtracting that entire product of 4 times x plus 5. This is us actively avoiding that number 1 trap. Now we just clean up the numerator. We distribute the x to get x squared plus 3x. Then, and here's the critical part, we distribute the negative 4 to get negative 4x minus 20. Then we combine the middle terms. 3x minus 4x gives us that negative x. And for the final part of step 4, we simplify the whole fraction. Can we factor that new numerator? X squared minus x minus 20? Yes, we can! It factors to x minus 5 times x plus 4. And this is the magic moment. The x plus 4 on top cancels with the x plus 4 on the bottom, leaving us with our final, clean, simplified answer. So that's the process. It's a system. But it's totally fair to ask, okay, that's great, but why? Why do we need to know this? Is this just some abstract algebra, or does it actually show up anywhere useful? This might just look like a random equation, but it's actually a model for calculating a final grade in a course. Each term represents a different part of your grade, maybe homework, quizzes, and the final exam, where the total points are related but still unknown. To actually solve something like this, you would have to combine these fractions using the exact skills we just built. This isn't just about abstract symbols, it's a powerful tool for solving complex, real-world problems. And now you have the plan to do it.